We continue in the series of questions where we are solving the questions which are based on graph. This question is a velocity time graph. Now, in the velocity time graph, how do you calculate the distance? So, if this is a velocity time graph, this area under this graph gives us the distance. So, to answer question number one, is asking us to compare the distance traveled in BC with the distance traveled in AB. So here we have BC, and the distance traveled in BC, we need to calculate this area. So you can see that this is a shape of a rectangle. So what will be the area of this shape? Now if you notice, this distance is t and this is 2t. So therefore this distance will be 1t. Okay, if you understand the logic, whenever you have distance, this is 1, this is 2, this is 3, this is 4. If you want to find the distance between this point and that point, okay, what you do, 4 minus 2, that is 2. 2t and t. So the distance will be 2t minus t, that is just 1t. Now what is the breadth? So this much will be the breadth, and that is equal to V0. So here you can see that this is V0. So therefore S1 is equal to T V0. Now if you look at the distance traveled in AB, you have to calculate this area. Now this area is a triangle. So triangle is half into base into height. So that will be half into T into V0. So that will be T V0 upon 2. This is the distance traveled in AB and BC. But they are asking us to compare. So comparison is a ratio. So therefore it is S1 upon S2. It is equal to T V0 upon T V0 upon 2. So this is like T V0 divided by T V0 upon 2. So T V0 and this get cancelled, and you are left with 2 upon 1. So the answer S1 is to S2 is 2 is to 1. Okay, so this answers the second part of the question. Now moving to the third part. Which part of the graph shows uniform velocity, uniform acceleration, uniform retardation? Now in a velocity time graph, when a part of the graph is horizontal to the time axis, that means velocity is constant in that. So the answer to that is BC. Uniform acceleration means with time the speed should increase. And as time increases, speed is increasing. That is this part. So that will be AB. That means with time the speed should reduce. So here time is increasing and speed is reducing. The answer is CD. Uniform means it's a straight line. That means with equal interval of time, the change is also same throughout. They are asking to calculate the magnitude of acceleration. Now, acceleration in a velocity time graph is calculated by taking the slope. Retardation magnitude is higher than acceleration. Now, the reason. If you see, the velocity has gone from 0 to V0 in time t. So you look from interval AB, the velocity was 0, and at B, the velocity was V0. And that has happened in time t. So the acceleration took t seconds. But if you look over here, at the time 2t, the velocity was V0. And then 2.5t, the velocity was 0. So the velocity was brought down from V0 to 0 in just 0.5t. So therefore, retardation magnitude is higher. Another reason you can say that the graph showing retardation, that is CD, is steeper than the graph showing acceleration, that is AB. Part they are asking us to compare the magnitude. That means we have to calculate the acceleration and retardation. So first, to calculate the acceleration, we need two coordinates. We need to find the slope, and at point B, it is t comma v0. So acceleration is y2 minus y1 upon x2 minus x1. It is v0 over t. Now we find for retardation and d, that is 2.5 t comma 0. So that is equal to v0 minus 0 and 2t minus 2.5 t. So that is v0 upon negative 0.5 t. Now 0.5 is half. So I write this as negative v0 1 by 2t, that is negative 2 upon t. Okay, now to compare it, we have to compare the acceleration and retardation. So this is a1 upon a2. a1, what we have got is v0 upon t, and the magnitude is 2v0 upon t. So therefore multiplication will give us 2v0, that is 1 upon 2. So the answer is a1 is to a2 is 1 is to 4. So this is the final answer. Now move to the next question. We have a velocity time graph, and this graph is divided into three parts: A to B, B to C, and C to D. Now in this three graph, if you have to describe the motion, imagine this is a road, a straight road, and there is a car at the starting of the road. Now the car is at velocity 0. Okay, then the car begins, it accelerates, and it covers a certain distance. Now by that time, when the velocity was 0, now the velocity is 30. So this is shown over here. So this is the time the car was speeding up. So that means the car was suffering uniform acceleration. Okay. Then what happens is the car maintained that speed. So you can see that here also the speed is 30. So that is B to C. And after that, the car slows down and the car is brought to rest. Okay, so at point D, the speed from 30 becomes 0. So the car does move in a straight line. Okay, it does not change direction. It starts from velocity 0, goes to velocity 30, maintain the speed, and then it is brought to rest. The first part, they are asking us to calculate acceleration. Now velocity diagram, if you need acceleration, you have to calculate slope. So we need 2 points. Okay, so for AB, the point I'm taking is 0, 0, that is over here. And the next point, you can see throughout the line, I can't get any points for sure because this is 2. Now 2 is corresponding to this. Now we can't guess that that's a midpoint. So I have to take this point, y2 minus y1, x2 minus x1, 30 upon 4, and that will be 7.5 meter per second square. For BC, it is a horizontal line, velocity is constant, so the acceleration will be 0. But if you have to calculate and show, one coordinate over here is 4 comma 30, and another can be 6 comma 30. You can take 8 comma 30. So any you can take, any two. So over here the acceleration will be 30 minus 30, and this will be 8 minus 4, that is 0 over 4. So A2 is 0, acceleration is 0. So in CD, I'll take the first point, that is 8 comma 30. Then I'll take the second point, that is 10 comma 0. So the acceleration over here, it is 30 minus 0, 8 minus 10. So 30 over minus 2. So the acceleration is negative 15 meter per second. So it is a velocity time graph. So we need to calculate the area under the graph to calculate the distance. So for the first part, that is AB, area of this region, which is a triangle. So S1 is half into base into height. Okay, so if you calculate this as the base, which is 4, and this whole thing as a height, that is 30. So this is 2 ones are 2 twos are. Answer is 60 meters. Now then for CD, this shape which CD will take, or sorry, BC will take, will be a rectangle. So we have BC, L into B. Now from 4 to 8, so that is 4. And breadth is this height, which is again 30. So that is 120 meters, S2. And now for S3, that is C. Okay, CD is this triangle now. So S3 is half into base into height. That is 8 to 10. This is 2. This height again is 30. It's 30 meters. So these are the distance traveled by the body in the interval 1, 2, and 3. Then the final part, they are asking us for the total distance. So that will be S1 plus S2 and S3, 60, 120, and 30. So that will be 210 meters. Let's move to the next question. This is a floor. This is a wall. Okay, so we have a ball over here. This ball is moving at a velocity of 10 meter per second, and it hits the wall, and then after hitting the wall, the ball is coming back with the same speed. Okay, it took 6 seconds for the ball to go from here to here, and it will take 6 seconds for the ball to come back. So if you notice the difference, this velocity is directed from left to right, and that velocity is directed from right to left. So if I say that this velocity is 10 meter per second, then I will have to say this velocity as negative 10 meter per second because the direction is opposite. So what does this graph look like? Or how does this graph, if we plot this graph, how will it look? In this graph, we can represent this as 10. Okay, so this is velocity meter per second. And this we can represent as negative 10. And this is time. So time is, and we can represent time as 2, 4, 6, 8, 10, 12, 14. Okay. So we know that this particular ball was moving for 6 seconds in the direction with velocity 10. 6 seconds. Okay. For 6 seconds, the ball moved with a velocity 10. And from the 6 second onwards to 12 seconds, it is moving with a velocity negative 10. So therefore, from 6 to 12, the velocity will be negative 10. Velocity and time graph. Now in this, the first thing they are asking us, what is the nature of the motion? So here you can see that the body starting from rest, in 4 seconds, it attains a velocity 2 meter per second. And then in 6 seconds, that is 2 seconds ahead, the velocity is again brought down to 0. So the second part of the question, they are asking us to calculate the total distance covered. Again, this is a velocity line graph. So the area under this will give us the total distance. Now this makes the shape of a triangle. So this is half into base into height. That is half into 6 into 2. The base is 6 and the height over here is 2. So we get 6 meters is the distance traveled. Now they are asking, the next part is to calculate the individual distance traveled in these time intervals. Okay, so let me call this as distance S1 and then this as distance S2. Now for distance S1, that is this triangle, I'm calculating the area, again half into base into height, that is half into 4 into 2. So that will be 4 meters. And for S2, again half into base into height. So this is 2 and this is 2. So that will be 2 into 2, that will be 2 meters, that is S2. Okay, now to compare it, S1 upon S2, that is 4 upon 2, that will be 2 upon 1. So S1 is to S2, S2 is to 1. That's the comparison. And then if you have to calculate average velocity, now displacement in this we have already calculated that as 6, and the time taken is also 6. So that is 1 meter per second squared is the answer. Okay, so these were the numericals, which were graph based numericals. Thank you.